surrounding area, the diversity of land uses, the design of the physical environment. Lastly, before I begin going through the methods, I also want to talk about the 3 different tiers or types of methods that are available for use to estimate multimodal or urban context-sensitive trip generation rates. And the first tier is the one that we really want to do the most, but it's all that's not available. We would love to estimate multimodal trip rates based on primary data. And by primary data, I would mean a robust set of person trip rates with multimodal information. And although some data like this exists, the methods to estimate these multimodal rates for a variety of land uses does not yet exist. But that's okay for the time being. We can continue collecting this primary data, and in the intermediate time period, we can use some secondary methods. The second type of method would be using primary data. You estimate vehicle trip rates based on primary data like ITE. This is what gives you an estimate of trip counts. And then you would adjust those rates for multimodal travel or travel in urban context using primary data that has also been collected. And there are 2 methods I'm going to talk about today that fall under this tier of method. The urban context adjustment, which was developed in Portland, Oregon at Portland State, and the smart growth trip generation adjustment, which was developed at UC Davis in California. A third tier of type of method to estimate trip generation for urban context would be using secondary data. And this is available for land uses where we do not have primary data robust enough to give us these estimates. So we rely on secondary data, which is sampled throughout the region. And in this type of method, you first estimate vehicle rates based on primary data. Again, IPE would be an example of this sort of estimate. And then you adjust these rates for multimodal travel using a secondary data set. And I'm going to talk about one such adjustment, the Household Travel Survey Adjustment, which was developed in Portland but has applications throughout the U.S. because it used multiple household travel surveys. And this is basically the structure for the next 3 adjustments. So first we're going to start with the urban context adjustment, developed at Portland under OTREC. As I said before, the urban context adjustment is an urban vehicle trip rate adjustment to ITE. So we're going to calculate ITE vehicle trip rate, and then we're going to adjust for urban context. We developed it in Portland, Oregon with the data set that we collected ourselves, a sample size of 78 stores, restaurants, convenience markets, and drinking places spread across the region. And then we collected an additional data from 34 establishments in the same region in order to test our method to see how valid it is, how well it works. Here is a map of the Portland metro area. I think 90% of you are likely to be familiar with this area. What I wanted to show is the 78 establishments that we collected were spread across the region. So we're not focusing just on the city of Portland or downtown. We're also looking at Hillsborough and Beaverton and Oregon City and Gresham. The urban context adjustment is actually a series of very simple models. And here on your screen shows the structure of this model. It contains 4 coefficients, 1 constant, and 3 variables. 2 of the variables, restaurants and convenience markets, are actually dummy variables. And all this does is tell us whether or not we're talking about a restaurant, a market. If it's neither of them, we're talking about a drinking place. The next variable, or the last variable, is the built environment variable. And what we do was allow users to select from one of 10 built environment variables in order to pick the model that best meets the data that they have available to them. So we didn't calculate one model, we calculated 10. And here on your right are the coefficients for all 10 models. To show you an example of how this works, I'm going to look at the built environment variable, urban living infrastructure, or ULI, and the corresponding coefficients that we estimated for that model. ULI is an index that was developed by Portland Metro. It represents the densities of retail and restaurant type establishments. So as you can see, the downtown Portland area is very dense. It has a very high value for its index, a 1 through 5 index. Along urban corridors and suburban cities, it also has a much higher index because those areas have a higher rate of these types of establishments. So in our example application, we're going to pretend we have a convenience market and that we would like to develop. And the location we're interested in has an average ULI of 2.9. So that's something that I had calculated previously. So if we look again at the map, a value of 2.9 is around a 3. This could be along one of these corridors. It could be in the inner east side. It could be out in Beaverton as well. So we start with the that I had showed you previously. And because we selected ULI as our built environment variable, we're going to plug in those coefficients. The built environment variable we're using is ULI. We're then going to fill in the variables. The ULI we calculated was 2.9. We know it's not a restaurant, so restaurant is 0. And we know it's a convenience market, so convenience market is 1. And I calculated the adjustment is negative 35. The next step is to adjust ITE's trip rate. To do that, to get a new adjusted rate, we add ITE's rate with our adjustment. So pulling ITE's rate, which I had previously done for convenience markets in the PM peak period, they have 52.4. We add the adjustment that I had calculated previously, and the final new adjusted rate is 17.5 trip-ins per 1,000 square feet gross floor area. And this is about 2/3 less than ITE's trip rate. As I mentioned before, we had collected data from 34 establishments in the Portland area. These are new establishments collected during the same period. And we used this method to estimate the trip rates and compare it to ITEs to see where we're finding improvements. And what we noticed is that this type of method of adjustment works really well for convenience markets and drinking places in the area, as you can see here. Restaurants tended to be predicted similarly for both the adjustment and ITE. There are many benefits to this sort of, and the first one, probably one of the most important one, is that it's very simple. You only need to calculate 1, maybe 2 measures of the built environment. There are several models to choose from, so if you know that you have good supplementary data for one of the measures but not for the other, you can pick the models that best meet the data that you have. And then it also uses recently collected data, person trip, primary data source as a means for its adjustment. But there are also limitations to this method. And the main limitation is it continues to have a limited sample size, which is why we pooled the different land uses into one model. We also are considering a limited number of land uses. We only look at 3 different land uses: restaurants, convenience markets, and drinking places, and all for the PM peak period. And the next study I'm going to talk about actually took the findings and the study methods that we were considering here and the limitations that we found here and was working to improve them. So the next method I'm talking is the Smart Growth Trip Generation model from UC Davis. This model is similar to the first one in that it is an urban adjustment to ITE, but instead of adjusting the vehicle, this method actually the total number of vehicle trips estimated. variable there is a little bit different. It was developed using primary data collected in LA, San Francisco, Oakland, and Sacramento. But then it was tested using primary data collected in Portland, Oregon. And this is the 78 sites that the previous study had used. And finally, they estimated two models, one for the AM peak and one for the PM peak peak hour models. They were also able to add a time period to this study. Additionally, they added a couple of land uses. They were interested in also residential and office land uses. So they have 5 total, where the previous study was looking at 3. And then they defined a set of criteria for their sites. So in the previous study, when we're looking at the map that I showed you, were collected across the Portland area. And this included everywhere from downtown to suburban locations and exurban locations. For this study at UC Davis, they were most interested in sites that could most benefit from an adjustment. And these are most what they would consider a smart growth location. And these criteria become important because locations that fall within these criteria perform best using this method. I'm not going to go into too much detail about the model itself, mostly because they provide an Excel toolkit on their website. So there's a link at the bottom of the page which will be available afterwards. Most of their documentation as well as their Excel toolkit is available. This toolkit is fairly simple. It has more inputs than the last model. You first start by inputting your ITE estimated total vehicle trips for that establishment. And then you define the environment through built environment measures, site characteristics including parking and building setbacks, information about the street in which the development sits on, the number of lanes, whether or not it has bike or ped facilities, and then some information about where this location is within the region, like how near transit it is, or if it's near a university campus. The toolkit also provides some simple outputs. It does all the work for you. It runs the model for you. And the main output that you get is an adjusted, estimated AM and PM peak hour vehicle trips, which are adjusted for urban context. As I said before, they did some testing using the data from the Portland, Oregon region. So they took the 78 sites that we collected here in Portland, and this was across the region, not just in smart growth locations. And they found that for 75% of these sites, their SGTG method predicted the estimated rate or the estimated total trips closer than ITE. Locations that met the smart growth criteria benefited the most. So of the 78 establishments, there were 20 sites that met the smart growth criteria or almost completely met the smart growth criteria that I presented on a previous slide. And for these 20, there were significant improvements in the estimation of trip generation rates. So if you have a location that fits within one of the land uses that this study looked at, and it also fits within the smart growth criteria, this might be an excellent method for you. The authors also re-estimated their model using the pooled Oregon and California data. They weren't able to test this method yet because they didn't have additional data to test these models, but all of their documentation can be found on their website. So if you're interested in using their re-estimated model with Oregon data, I suggest finding their documentation on their website. The benefits and limitations are actually very similar to the first study. They were able to use recently collected primary multimodal data. They added a time period, so they were looking at both AM and PM peak time periods, and they looked at a few land uses. The limitations here are also the same. They still had a limited sample size, which is why they pooled their land uses into one big model. They still had a limited number of land uses as well. Looking at 5 land uses is still a fairly small set considering ITE's handbook has over 160 land uses. Additionally, they control additional variables. And by using more and more variables with a smaller sample size, this means they had less statistical power in their models. This doesn't necessarily mean that their coefficients would change, but what we don't is whether the variables we're including are significant in controlling or significantly different from 0 in controlling for changes in trip generation. Both of these previous studies had similar limitations, and they sort of centered around the limitation of a lack of primary person trip multimodal data. And so there's that third tier of method that I talked about earlier that we can use to sort of supplement and fill in the gaps where we do not yet have enough primary data. And so the third method I'm talking about is the household travel survey adjustment. And this is actually my thesis, so I'm intimately familiar with this method. It's similar to the other methods in that it's an urban adjustment to ITE, but this method provides both multimodal and vehicle trip adjustments. It was developed using secondary data, specifically household travel survey diaries, but I used data from 3 regions: Portland, Oregon, Seattle, Washington, and Baltimore, Maryland. I pooled these household travel surveys to develop these models to account for variations across different regions. I also collected some primary data in order to test this method. I had 195 points spread across 13 different land uses. And the output study was multiple models for 9 different land use types. So to review the difference between primary and household travel survey data, I just have a few graphics to show you. Primary data, specifically the state of the practice primary data, IT's trip generation, is really just looking at one establishment at a time. And it's focusing on only the people that drive to that establishment. Now this is different from household travel survey data because household travel surveys sample from the household. And they collect all travel for each member of the household for the entire day, or possibly 2 days, depending on the survey. So household travel surveys are able to a few trips to many, many different locations across the region. They're able to get multimodal information, vehicle trip information, and lots of other person and household characteristics for the people traveling to these establishments. So in order to use these household travel surveys, the majority of my time was spent organizing the data to be similar to ITE's trip generation handbook to allow the model and the method to be compatible with the handbook. Part included looking at trip ins. So looking at each of these travel survey diaries, we pulled out observations where anytime a person entered a store, we counted that as an observation. When they left a store, that was another observation. That way, the data that we're using to estimate this method is comparable to ITE's trip generation, which looks at trip ins at any one establishment. I then took these observations and classified them by the time of day, AM peak period, PM peak period, midday, the day of week, including a control for Friday, which sometimes has different travel patterns than other days of the week. And then I also included an indicator for whether or not this travel happened during the winter months, November through February. I also used supplementary data looking at every observation and the establishment in which people were patroning, and I collected information to describe the built environment. This included population density, employment density, intersection density, percent retail employment in the area, many, many different characteristics. I also included an indicator for whether or not that location fell within a half mile of a transit-oriented development to control for whether or not that area had access to light rail. And then I looked at how far that location was from the central business district. As a very crude way of controlling for regional accessibility of that location. As a result, for 9 different general land use categories, I had 2 different types of estimate models. The first one was actually a very simple mode share table. And this is simple because the only measure you need to calculate is activity density. That means residential and employment densities in the area. You simply find your activity density along the table for that given land use, and then you have or mode split found within the 3 household travel surveys. So this provides multimodal information, bike ped information for that type of establishment in that type of activity density. The second type of adjustment that this method provides is a more detailed multivariate regression, actually several regressions for each land use, each controlling for a different measure of the built environment. In these regressions, I was also able to control for the additional travel information I collected. This would be like time of day, day of week, winter months, distance from the CBD, and so on. To show you an example application, I'm going to fall back on our example of a convenience market that we want to develop. We're going to assume that we want a 2,500 square feet gross floor area convenience market, and we're going to use ITE's trip rates in order to estimate the total vehicle trip-ins for that establishment using ITE's suburban vehicle-oriented data. So as a result, we get 131 vehicle trip-ins. Next, we're going to apply some assumptions to convert ITE's vehicle trips into an estimate of person trips. Now, ITE doesn't provide a lot of information for all of its land uses to describe what sort of automobile mode share or vehicle occupancy rates occur at the data that they have collected. But we can make some assumptions based on the fact that they state that their data tends to be suburban, tends to be vehicle-oriented. So for the purpose of this example, I assume that all cars traveling to ITE's data establishments are 100% automobiles, and they have a vehicle occupancy of one person per vehicle. So using this equation, we estimate that the ITE data has would estimate a person trip rate of 131 person trips to our establishment. The final part of this is to redistribute these person trip estimates into their urban context modes based on the equations and lookup tables that I was talking about earlier. So here we use a very similar equation where we apply an automobile mode share or a bike mode share, depending on which method you use or what you need, and the vehicle occupancy rate for that urban context. And these equations are provided in the method. I'm not going to show you them or work through them here because I only have a limited amount of time. But based on the definition of the problem statement of the hypothetical example that I'm talking about now, if our convenience market was to be located in an area 8.8 miles from the CBD, not next to a transit-oriented development, with a population density of about 7 residents per acre and an activity density of about 14 or 15 people per acre, what we would get would be an automobile mode share of about 91% and a vehicle occupancy rate of about 1.2 persons per vehicle. And using this equation to convert ITE's estimate of person trips to an estimate of vehicle trips adjusted for urban context, we get 103 vehicle trips for our hypothetical convenience market example. As I mentioned before, I also used independently collected primary data in order to test this method. I was able to gather 195 points at different times of the day for 13 different types of establishments. The majority of this data came from Portland, Oregon, and as well as California, so the Caltrans Kimberly-Horn study I have cited there. And then ITE gave me some newer data they had collected that hadn't yet been incorporated into their informational report. And these are the data I used to test this method. In general, here were the on the left side were the 3 land uses that ITE appeared to do a clearer job of estimating the trip generation rate. In the middle category were 2 land uses where both ITE and the adjusted rates appeared very similarly. On the right side, there were several establishments where a simple household travel survey adjustment really seemed to benefit this method well. And so the main results from this study were that for many land uses, a very simple adjustment may benefit the estimates just as well as some more complex adjustments. In general, one of the main benefits from the study is that it was really developed from data that was collected from multiple regions. We're not necessarily focusing on Portland here. Instead, we're bringing in behavior from Seattle and Maryland and testing it from data in California and in the Northeast. We were also able to estimate some multimodal mode splits, which allows the user, the practitioner, or the agency to give an estimate for non-automobile trips generated at these establishments, which right now isn't available. We also were able to test it using quite a bit of data collected during different time periods for 13 different land uses, which was a lot of data, actually. But the limitations of that were when you're looking at 195 different data points and you're spreading it against 13 different land uses, it's still tested for a limited sample size. So some of the land uses that we looked at only had a small handful of data points. I recommend, if you're interested in this, I recommend looking at the documentation for more information about what we found. Another limitation would be that this adjustment is not based on primary data or trip counts. It's built from secondary data. So we're making a number of assumptions about the ITE's data and about our adjustment in order to apply it. And without a detailed primary data, we really can't test these assumptions yet. And so in conclusion, looking at the 3 methods that I presented to you today, we were talking about 3 off-the-shelf, ready-to-use adjustments that allow users to account for urban context when they're estimating trip generation rates. They all have the same limitations, though. For one, we really lack the multimodal person trip primary data that we need in order to either make more robust methods to estimate multimodal trip generation rates or to test our assumptions to see if our methods are valid. All 3 of the methods presented today and many of the other adjustment methods that are available and out there are really just stopgap alternatives. They're just helping us bridge the gap from the point where we have no robust, detailed, rich primary data, person trip data, allowing us to account for urban context until we get to that point where we can start compiling databases for individual land uses and doing further analysis there. So in general, my point is that we really need to find a way to collect consistent data that represents people and not just cars. This is the limitation of the majority of the adjustments out there, and this is what's really holding us back from furthering the state of the practice in the U.S. And as we're collecting this data, what we really need to consider now is developing a consistent framework for collecting the person trips and the multimodal data collection. There isn't right now a method or guidelines that are published and endorsed by people in order to collect person trips and multimodal data. And as a result, as people do their individual studies, each of their surveys is unique, and they're not necessarily able to combine studies and to combine the data, which is again holding us back from creating a database of many, many different points that are collected across the U.S. And that was the point that I wanted to end on. So I'll turn it back to Hal and open it up to questions.
Okay, great. Thanks, Christina. For those of you viewing the webinar, please feel free to continue to submit your questions. We do have a few questions that folks have sent in, so we will start from the very first question that was submitted. Does IT overall lack sensitivity to urban context or just the trip generation manual?
I guess I can't speak. When you refer to IT, I'm assuming you mean the group as a whole. And I would say that the group as a whole does not necessarily lack sensitivity to urban context. In fact, I think they've made strides to publish topics and push towards getting forums and tracks within their conferences to really look at context-sensitive solutions. In fact, I think that was the name of one of their manuals that they published. I think the trip generation as well as the parking generation do lack urban context, but I think part of that is because it's an institutionalized practice, and it's very hard to change something like that. They're aware of it. They've had ITE committees that have been looking at incorporating person trip chapters and urban context adjustment chapters within their manual. I'm not sure of the state of that. It's my understanding that they're looking at announcing those features at their annual meeting in August, but it's not clear how much will actually get incorporated, which makes it very difficult. But.
Okay, great. So the next question, I'm a big believer in moving to continuous data sources as opposed to point data, one-day survey, one day count. I think a great source of multimodal continuous data could be signals, which would obviously be a rich data set for an urban location. Any thoughts on how sources like signal data or cell traces could be used in the future?
Oh, that's a good point. And there's actually a lot of discussion on passive data collection and incorporating that into this practice. The main problem that I foresee in using signal data specifically is that we're really focused on establishments in this type of estimation and not necessarily an intersection. We have talked a little bit about the possibility of using Bluetooth sensors in the way that I believe Powell Boulevard in Portland, Oregon has Bluetooth sensors that track the speed of the traffic. The problem with that is not everybody has Bluetooth, and we're really interested in total counts. Another thing we've been exploring here at Portland State is the use of ultrasonic sensors as a means of counting people and then applying intercept surveys in ways where we can collect data for a week or that sort of thing, where we can have cashiers implement very simple surveys, have the data be automatically entered, and so on. I think the Bluetooth idea is possible, or that sort of signal idea is possible, but again, the main limitation is if everybody doesn't have a phone or that sort of technology, then not everybody will be counted.
Great. So for residential locations, the main driver of trip generation is demographics. Mm-hmm. Is there a reason why California's method didn't try and account for the demographics residential location?
You know, I believe they did, and I highly recommend, again, looking at their documentation. That is definitely something we talked about, and I would even argue that all types of establishments are affected by the demographics that typically serve them. If you look at grocery markets that cater to higher paying customers, those demographics are typically higher. What we haven't seen is a lot of establishment or intercept surveys that collect that information and then control for it, because we don't know in what ways that information at the establishment level affects trip generation rates. But that's definitely a gap in the the trip generation literature in an area for future research.
So do you know if, have any of these methods been vetted by ITE or adopted by any cities?
All three of these methods were incorporated in one of the preliminary chapters of their urban context adjustment to the new, what would be the 4th edition of ITE Handbook. I believe they still have to put the handbook out for votes from the ITE members, so it hasn't officially, none of them have officially been adopted. But ITE is well aware of all three of the methods, as well as some of the corresponding papers that we've written on data collection for person trip rates and stuff.
Okay. And has the study been published? Carrie Burkhouse is interested in seeing a breakdown of the adjustment factors and additional documentation.
For which study? All of them?
All of them.
The first two are actually both forthcoming in the Journal of Transportation and Land, or Transport and Land Use. This is a peer-reviewed journal. The Smart Generation Study has a website with their full documentation. Their urban context adjustment has a forthcoming article, but also has an OTREC report that is published online, and I believe the link is in my bibliography here. So feel free to find the sources there. The final method, the household travel survey method, is under review in a journal article, but the full dissertation and theses, the link is provided here in the middle of the page for the full documentation, and I'm happy to answer questions or provide a draft of one of my working papers if that helps simplify that for you.
And we will be sharing the presentation online as well, so look for that email that we send out after the webinar. So the next question is, are you suggesting that ITE rates have an occupancy rate of 1, or was that just an example, and that the user would have to make some assumption of what the ITE occupancy rate would be for a given generation type?
Yeah, it is just an example. The main point of using 1 is that ITE does not always provide that information, mostly because they don't know it. People don't submit that information usually when they're submitting trip generation rates. If you have more detailed information about what you believe vehicle occupancy rates in ITE-like circumstances are, so in suburban automobile-oriented locations, feel free to make those assumptions for both ITE's vehicle occupancy rate or automobile mode share. And in some cases, ITE does present that information, so definitely check the informational report under that land use.
Okay. Do you feel that the household travel adjustment could be strengthened by other regional surveys? For example, other data sets on the Metropolitan Survey Archive? Oh,
definitely. The main reason why I chose those 3 were because those were the 3 that were available to me where I had the XY coordinates of every location that people stopped at. If I had to pick, if I had my dream wish, I would love to have a Midwest, maybe a Minneapolis, maybe something further south in Texas or Louisiana, Georgia, something like that. It just depends on whether information is available at an XY, at a more spatially refined level of analysis.
Great. So we have another question here. What methods can be used to calculate latent demand as opposed to existing or historical multimodal trips, but future projected demand for walking, cycling, and transit and car sharing, etc.?
Oh, that's a really good question. I don't think any of these methods really can be, because we just don't know based on these results. I think if you're looking for a method that estimates latent demand, you could look at surveys that have been done, stated preference surveys for this sort of travel that have been done. I don't have any off the top of my head, though.
And have employer-based commuter surveys been used much the same as HTS?
You know, I haven't studied employer-based surveys specifically in office-type situations. One thing I do know is that ITE's office categories of trip generation rates are very old. They're definitely not recent data. For developers, I think if they have an office and they're able to survey their employees, that would definitely be probably the best way to collect information about that company specifically, because companies have different policies, cultures related to how people are likely to travel. So that would be the best way, but it'd be similar to a household travel survey in that application.
Okay. Have any of these adjustments been used to update municipal policies, such as parking requirements or development charges?
Oh, that's a good question, too. I can't speak for the California survey. On their website, they have contact information. You can always ask them. For their urban context adjustment, that was, I believe that was in some way the intent of that project. It was sort of to start something that helped inform system development charges. And toward the end of that project, I remember we had some conversations about that, but I don't know if they've actually used it. We haven't been as involved with them. That would be a question for, if you're in Portland, that would be the question for the Metro group.
Okay. Another question, do any cities have their own database systems for collecting trip generation data for development applications?
That is a wonderful question, and I have a bonus flag for that. Here are some alternative data sources. These are fairly limited, but in this second category here, the second and third, New York, Virginia, and San Francisco are all U.S. cities that have started collecting their own data. And New York has their own trip generation informational report, if you will. They prefer that nobody uses ITE, mainly because New York is such a unique city. Virginia, it has an online system. It's free. The link is in the bibliography at the citation. You can go on and look at how they present their data. And then San Francisco has collected their own data based off of traffic impact analyses and has really incorporated that data with ITEs in order to make a local adjustment based on different districts within their area. Outside the U.S., a couple other sources know who might be developing outside of the U.S. Australia and New Zealand have sources that, as far as my understanding, very similar to ITEs. In some cases in Australia, I believe they prefer you use ITE. TRIX is definitely, in the UK and Ireland, is definitely the most detailed data source. This is probably the forefront of this area of research, in that they collect person trip and multimodal information and really provide a lot of detailed research for people who are subscribers.
Okay. And it looks like we have one more question from the audience. Did these adjusted trip generation outcomes lead to any specific changes to development or infrastructure?
That is a really good question, too. And I have one anecdote to something that we noticed. When we did this study, we partnered with a company that has lots of convenience markets. So they were our main source for convenience market data. And after presenting more detailed results, specifically about their locations and what we were noticing, we noticed even in suburban locations, people were really walking and biking a lot, and a lot more than we thought we would see. They went back after that meeting and installed a whole bunch of bike parking at almost all of their locations across the Portland region. And so in some ways, that's probably the only recent development of or change of infrastructure based on these reports. Otherwise, I think it would be a while before we see changes according to development.
Great. Thanks. Thanks, Christina. So this concludes our webinar. I just want to thank everyone for taking time out of your day to join us. We are looking for your feedback so that we can improve and offer more relevant webinars in the future. So be on the lookout for an email with a short evaluation survey as a follow-up. We will also post the slides as well as a recorded audio recording. So if you'd like to share this webinar with other folks, please forward on that information to them.